welcome to this presentation. Today we will explore a comparative study on stock index forecasting based on deep learning and traditional time series models, evidence from the CSI 300 index. And we will walk you through four main parts. First, the research background and purpose. Second, the dataset and the environmental design. Third, the main results and the model analysis. And finally, our reflections and future prospects. Let's start with the research background. Predicting financial markets, especially stock prices, has always been a major challenge in finance. Traditional models like ARIMA are widely used, but are limited by their linear assumptions and sensitivity to sudden market shifts. In contrast, deep learning models such as LSTM and Transformer have shown strong potential in capturing complex nonlinear patterns and long-term dependencies in data. Therefore, this study aims to systematically compare the classical ARIMA model with a hybrid LSTM transformer model for forecasting the CSI 300 index from 2023 to 2024. We will evaluate their accuracy, robustness, and overall performance. We use the daily price data of the CSI 300 index from the Wanda financial database. The data was cleaned, normalized, and divided chronologically into a training set from December 2022 to May 2024, and a testing set from June to December 2024. For ARIMA model, we used only closing prices, and for our STM model, we included multiple features such as open, high, low, close price, and some technical indicators like MA5, MACD. The data was structured into 20-day sliding windows to predict the next day's closing price. Okay, let's see the ARIMA model. It uses autoaggressive and moving average components to model linear relationships in stationary time series. We applied the first order differencing to achieve stationarity and selected the parameters based on autocorrelation plots. And now you can see the picture. Really, ARIMA captured the overall downward trend well, but showed noticeable lag during sharp market rebound. It struggled to adapt to a sudden reversal. And here are some quantitative data results. From the data results, we can see that while it faces persistent trends, it reacts slowly to abrupt market changes.
Okay, let's begin with the deep learning model. Our group built a LSTM transformer hybrid model. Different from the traditional ARIMA model, we added other 7 key features such as open price, trading volume, and 3 technical features, MA5, MACD, RSI, to ensure LSTM transformer model better learn and predict the results. The model's first step projects the 9 input features into a 12-dimensional space using a linear layer. The data then passes through a 2-layer transformer encoder with full attention depth. This calculates relationships between all data in the sequence, helping to capture sudden markets, events, and complex patterns. Next, a bidirectional LSTM processes the sequence both forward and backward. This provides a deeper understanding of temporary dynamics by considering context from both past and future data points for any given day. Finally, the 64-dimensional output vectors from the LSTM's last time step is fed through a fully connected network to predict the next day's closing price. With our training set spans from January 2023 to June 2024, and the test set covers the period from June 2024 to December 2024. As can be seen from the figure, the accuracy of our model for the CSI 300 index continuously improves over time within the training set, with the test set also demonstrate exceptionally high accuracy. Well, okay, let's compare the two models. On the left, the ARIMA model struggles. You can see it lagging behind at major turning points, especially from September to October in 2024. With the market anomaly by a policy-driven bull market, it is difficult to capture and predict by the traditional model ARIMA. On the right, our LSTM transformer model's prediction stays very close to the actual price, navigating the volatile periods with stability. We use the MAE, RMSE, MAP, and R-squares to compare the models. From the statistic comparison, we can know our LSTM transformer model outperformed ARIMA across every single metric. I want to draw your attention to the RMSE. This metric is very sensitive to large mistakes. The fact that our model reduced this error by over 22% is direct proof that it is more reliable and avoids the dangerous large-scale errors that the traditional model is vulnerable to. Finally, through comparative analysis on the Chinese CSI 300 index, we conclude that the LSTM transformer hybrid model significantly outperforms the traditional ARIMA model in terms of frequency, forecasting accuracy, and robustness. And although the LSTM transformer model performed well in the case study, several points we can explore in the future. Firstly, we can incorporate more alternative data sources such as sentiment scores from the financial news based on NLP and so on. Secondly, we can experiment with more advanced deep learning architectures for time series, such as deformer or autoformer designed for long sequences. And thirdly, we can expanding prediction targets. That is all of our presentation. Thanks for your listening.